Good afternoon, everybody, and welcome to the second edition of the Rise of IoT and Big Data in Rail virtual workshop. My name is Ben Holliday, and I'm the Managing Director of Rotea Media, the organiser of today's event. I'd like to start off by thanking each and every one of you for registering to attend today. The interest in today's workshop has been very overwhelming, so thank you all for sparing the time out of your busy days to take part. I'd also like to extend a very special thank you to today's speakers, Gerrit Cockter-Cracks, Miko Alenko, David Duval, Martin Ziskovits, Francis Shapiro, and also our moderator, Daniel McGregor. Quite simply, without all of your support, today wouldn't have been possible, so thank you once again. As many of you all know, unfortunately, we had to postpone the physical event this year due to the coronavirus. However, I'm very pleased to inform you that we now have a new date confirmed for next year, which is the 26th and 27th of May in Cologne. To find more information about the event, please visit iotandbigdatainrail.com to learn more, or alternatively, in the handout section in your profile today, you can actually find the PDF document, which is the program for the event itself. Additionally, there is also another PDF document in the handout section, which is the program to another event we're organising later this year called Scandinavian Rail Development, taking place in Stockholm on the 10th of November. All it leaves me to say is thank you very much once again for joining. I hope you enjoyed today's session, and I'd now like to pass you over to Daniel McGregor, the co-founder from the company Nexia. Many thanks.
Hello, everybody. So yes, indeed, I'd like to follow up and say thank you to all of you for joining. We're meeting again online. I think by now we're getting used to this format, and it's really great that so many of you could join us today. It's a very special event, as Ben described, from Rotea Media. It's connected to the rise of IoT and big data in rail. And today we'll be focusing specifically on using IoT systems to deploy predictive maintenance and fleet management efficiency through the intelligent use of smart data. So I extend to all of you a very warm welcome and a huge thanks to Ben and the organising team. Obviously, it's an online event, but it still takes a lot of organising, and a big thank you on behalf of the entire industry. So it's free to register and attend, and we're grateful for this opportunity. And it's critical, I think, to have these touch points for us to coordinate, compare, and to collaborate. Well, we're all in this together, as they say. And from the interest shown and the attendance figures, it's clear that it's highly valued by everybody. We've seen again another increase in the number of participants, and we've got an excellent lineup of speakers for you today. So we look forward to another interesting session. Quick intro on myself. As Ben mentioned, I'm the co-founder of Nexia. We're a leading enabler in the digital supply chain, and we focus on collecting data from rail freight wagons and other mobile assets. We leverage this to create improved performance for our customers and to create new services and data-driven value for the customers of our customer or the cargo owners. So we live in a time of rapid change, and we obviously find ourselves caught up in the language of change. I think these events are very useful to manage this language and to unpick what we mean and to get to the bottom of the purpose and the objectives and so on. So we try to avoid the buzzwords and get behind the buzzwords today. As a community, we've been scoping IoT and big data in rail for a number of years, and we've made some fantastic progress. It's great that we can take some different perspectives and engage in some healthy debate. So I'd like to encourage that today. We'll also focus today on the asset side, so on the fleet and the components and the processes around these mobile objects. In case you missed the last one on digital infrastructure, it's available through the event website. So taking the angle today more specifically, how are we using the data, and more specifically still, how are rail operators and leasers using the data and integrating IoT solutions into their company's processes. We'll also take a look at why we're doing this and look at some examples of asset utilization, availability and maintenance. We'd like to know what real visibility means. What does it mean today and what will it mean in the future? Without further ado, we'd like to get on with the speaker program. We've got some great speakers today. So I'll welcome the panel soon, but we're going to take each individual speaker at each stage. This is the first speaker is going to give us some insights into asset digitization within his organization. We'll discover something about the Wagon Intelligence project, including some pitfalls that they discovered along the way. We'll look at the forthcoming digital agenda and how IoT data is made truly valuable through integration into business processes. So from DB Cargo, the head of Wagon Intelligence, I'd like to introduce Mr. Gerrit Koch de Krax. Here we are. Thank you.
Thank you, Dan. And thanks, Ben, for giving me the opportunity to today tell you something about asset digitization at DB Cargo. And let me say I'm sitting in Frankfurt in our offices right now today. It's raining, and I would much rather be in a conference center location to talk to you in person, because I'm let's say done with online meetings and WebExes and Teams calls. But moreover, I think it's very important that we get the chance to get together today and discuss asset digitization and what it means to us and our organizations and our people. Yeah, that works perfect. I'm going to show you something about my project, Wagon Intelligence. I am the project manager and head of our team of around 25 people in the organization of DB Cargo in Frankfurt, working on digitizing everything in the value chain around freight wagons. We are, or from my education, I'm not an IT guy, so don't bother asking me any IoT technical questions I would probably not be able to answer. But I am very experienced within the freight wagon business within DB Cargo. I had several positions in asset management, from procurement to using and remodeling freight wagons. And since 2017, I am heading the Wagon Intelligence program within DB Cargo. So, as Dan said, I'm going to show you something about the achievements we've made. Where are we at right now within the digitization of asset and especially freight wagon management? Let's start with the rollout. So we're talking about hardware. We're talking about GPS devices, shock sensors, empty loaded sensors, and also for the specific fleets about temperature and humidity sensors. Within DB Cargo Germany, we are looking at around 65,000 cars we want to equip with telematics and sensors, and we're going to finish this by the end of the year. Today we have achieved, or we have equipped around 53,000 vehicles with telematics, and let's say we have made all the experiences that you can make with rolling out hardware in a very analog asset, without electronic interfaces, without batteries. So yeah, we have learned a lot about that, and also about training our maintenance crew to mount those devices and connect them with the freight wagons. The other part of the project or the program is to get deep in the digital needs. So what we did when we started in 2016, we designed our own workshop set to see what are the digital needs of our customers. When I talk about customers, I don't mean our freight customers in the first place, but our internal customers within customer service, sales, service design, maintenance, operations. So all of my colleagues who are at any kind connected with freight wagons, and we took them together and we went through various design thinking stages to see where can telematics data be helpful at. So how can we use it? What is the process looking today? Where are the pains? And what could the ideal user journey look like in the future? So we went through this phase, and we're still going through this phase as it is a continuous and agile IT development we're doing here. And what is the outcome? The effect I showed to you the downside of this slide. So we decided to not use the devices and we decided to not use the platforms and the tools made available by the suppliers of telematics, but to design our own devices, as we have learned that it is crucial that they are connected with our company data, so with transport plan data, customer service data, maintenance data, and that they are tailor-made to the processes we want to digitize. The outcome is, and I have to say this very proud, is that we are have supplied the dashboards and tools, and they are used by 600 to 800 customer service agents, dispatchers, service designers every day within our big customer service locations in Germany, and also our affiliates within Europe, DB Cargo in Spain, DB Cargo in France and Poland, for example. They're all getting the taste of what wagon digitization could look like, and they're interested. They're asking for it. They ask, how could we use it? How can we implement wagon intelligence in our organization? And also, some of our customers ask us, because they also maintain and operate more or less big freight wagon fleets. How can we use those tools that you've developed? Because we know that what you've done here is tailor-made for where we undertake us. So what are we doing? We're trying to reduce wagon cycle time. Wagon timer is indicating where are our wagons, are they stored, are they loaded, are they unloaded? And to bring this to the attention of our dispatchers when we have idle times of the wagon that are above the thresholds. We use the wagon operator to get a forecast of our wagons in the shunting yards. So our single wagon managers, single wagon operation managers get a 3-day forecast for their shunting yards, what is going to go through their yards. Do they need to change staff or change locos or shunting procedures to improve the flow in those yards? And we're also using geofencing and billing tools to automatically invoice demurrage within certain countries with certain customers. These are the, let's say, live applications, and we also built analytics tools within Tableau that are mainly used by our service designers and by our sales guys when we try to figure out how the traffic that we've planned actually run and what are the specific needs of certain customers. So we supplied wagon intelligence tools in a big variety to our internal users, and since February this year, we also supply telematics data, and in this case GPS data, to our external customers. So within the sales digitization program Link to Rail, we offer track and trace APIs and track and trace portals for shipments, so that our customers can book on an track and trace API that is no longer only fed by existing systems and manual entered data, but also from telematics data, and especially outside of Germany, where the transparency gets lower and lower from our perspective. This is really helpful. It helps our customers to schedule their charging and discharging crews and also their production procedures. So yeah, as I said, we're going to finish up with working intelligence by end of this year. Some last works need to be carried out next year, but the basic steps we're going to reach this year. And 2 slides later, I'll be pleased to tell you something about what's coming next. But first, Ben asked me to show something or talk about the learnings we've made in this digitization process. And as I said in the beginning, we have probably taken all the pitfalls that are available or that are possible to take. Know your legacy, and I talk about the IT that is already there. We're not working on the green field. We are in very deep and old brown field. And I'm also talking about the IT projects and digitization projects that have been there before us and our teams have been confronted with, because in many cases they're very worn out. They are not trustful anymore in new IT projects because there has been so much, and we have to convince them every day that working intelligence tools and dashboards and interfaces and services are something different. We also, when we design the use cases and the tools, I think, let's say 3 or 4 cases we started development, and we saw later that the data quality of the existing systems that we needed was not sufficient to follow up on this use case. So before we start developing, we integrated thorough background and data quality and availability checks. And we are investing into this steps of process, even if they cost time and money. It's so important to know what data quality we're looking at, and especially with DB Cargo, with IT systems that have been developed between 1970 and yesterday. Everything is possible, and especially when it's based on manual inputs, quality can be very, very different from time to time. Know your use and business case, and I always bring these 2 cases in combination, because what we first do when we talk about telematics and wagon intelligence, we talk about hardware. What do we equip on the wagon? What is it? What does it look like? What is possible to do with it? And then we talk about possible use cases. So we can measure the location of the wagon. We can see if it's empty or loaded. But within a refrigerator business, say within DB Cargo, this is not enough to convince our leaders to fund and budget those projects. We always need to come up with a certain business case. And when you then think about how those tools can be used, you get very quickly on seeing that it is necessary to transform your business and your people, and to integrate those tools into their daily procedures to really get a return on it. Stay focused. This is one of my main tasks as a project manager, to keep my team focused. Once you've shown that you are able to develop IT that works, that really helps, people, managers, stakeholders, they all come and ask you to develop something for them to solve some of their problems. What on the one hand is really good. On the other hand, if you try to make all of them happy, you will make no one happy. And also, if you have a team that strives for digitization, that works in agile software development with modern hardware, they're all very interested in all the stuff. They usually want to try some other products, to check on other technology, prototype something, and keep them focused on a clear line is one of the key success factors. Another thing that I'd like to emphasize is competitive knowledge, or especially in this case, to keep the digitization knowledge within your organization. We experienced in many cases that we have consultants or freelancers on crucial positions within the coding, also, and even more important, within the business transformation, and they left after a certain time, and they leave holes that put you back to the beginning, because at least sometimes it puts you back. at the start, and you have to gain this knowledge again. And to all leaders and decision makers within organizations, my advice is to very thoroughly look at what positions you want to keep in your organization, which people do you want to have for a long time, because digitization is not a one-time effort. It's a really long game we have to play here. And my message to all suppliers out there and all other railway undertakers: organize and standardize. Besides staying focused and keeping my team focused, organization standardization is one of my key tasks. For an example, DB Cargo is operating 400,000 freight cars every day, but we only own 80,000. So most of the cars we have are used by or are owned and operated by other organizations, and we need to standardize those interfaces and keep data organizations and interfaces standardized so that we can use this data. So, and to just quickly show you what is next, as I said, we're going to finish up with Wagon Intelligence this year. I want to talk about how we are going to integrate this data into our processes. Right now, we're having dashboards, we're having tools for dispatchers, for customer service agents to do their usual job with. But tomorrow, I want to integrate the telematics data, the enriched telematics data, into our processes. Via event streaming, we're going to create telematic events. For example, the shipment has arrived at customer siding and the car has been unloaded into our background IT, and automatically initiate empty wagon disposition. So that, differently as today, there is no longer a dispatcher who needs to dispatch the empty wagons, but the system that is already in place today knows that the wagon is able to be dispatched and is going to do this dispatching automatically. So I'm right now preparing the next project. It's called Value-Added Business Events, and we are going to integrate data in those processes. It's not as sexy as equipping cars with hardware. That's something you can touch, you can see, you can feel. But from the faces and the reactions from my colleagues that I'm talking to about value-added business events, I get the strong feeling that they are already as mature as they understand how important it is to integrate the data into the backlying IT systems to transform the digitization to the next step. So this will be our task for the next 1 or 2 years, and I'm really excited to go that way. Thank you for giving me your attention, giving me the opportunity to talk to you today. And if you get the chance to scan the QR tag, you'll get a short video of Wagon Intelligence, but you can also find it online. And if you want to get in touch, talk about digitization or equipping your fleet with telematics, or you need some dashboards and tools for your fleet management, just get in touch. Thank you, Dan.
Thanks so much, Gerrit. It was a really interesting presentation. I think it was very practical, and you know, there's some really useful takeaways. You know, it's not long. 15 minutes isn't long, and you know, you gave us some really great hints. I think it was particularly interesting to see this topic about keeping the knowledge in house. This is something that's been a long problem for any sort of transformation project and so on. You need to bring in expertise from outside, but you certainly don't want to lose IP that you've developed in house. And then the other bit that you mentioned, you said that you think the devices are a bit more sexy, but they're not so sexy when they've been running around on the rails for a few years. The business processes and the things that you can do with the data is definitely, you know, the hot part of this process now, and the devices were the enablers. So thanks so much, Gerrit, and we'll catch up again shortly for the questions panel session. Now I'm going to introduce our next speaker, so if you want to turn your camera off, Gerrit. And so now we're going to unlock some opportunities in asset condition monitoring, and specifically I think, on the bogie and the wheel sets of passenger coaches. So a slightly different angle. It's less on the cargo angle, but still, you know, it's about rolling stock and about digitalizing the rolling stock. We see how IoT and analytics and technical expertise and domain knowledge as well can be brought together to extend the maintenance intervals. We're going to hear some more about that right now. So from VR Fleet Care in Finland, the VP of Digital Services, I welcome Mr. Mikko Elanko. Hello, Mikko. Welcome. The floor is yours.
Thank you, Daniel, and greetings from the sunny Finland. So as Garrett said, that he would rather be in the conference room than in the office. So you might not be surprised if I say that I'd rather be here in my summer cottage and enjoying summer at the moment. But thank you for the opportunity to have this presentation to you. My name is Mikko Alanko, and I worked for the VR Group, which is the Finnish National Railway, so for the last 9 years. And the last 3 years I've been on our maintenance unit, and then my responsibilities have been to create the predictive maintenance capability and how to use and then make predictive maintenance in Finland. And I was asked to give you a presentation about a true case that we have, and that's what I'm about to do now. So one couple of slides about VR Fleet Care, what we are. So we are a subsidiary of the Finnish rail operator VR Group, and we were established in 2018. And then before that, we have been the last 156 years as a fleet maintenance company or a fleet maintenance unit of VR. And so now we are a semi independent fleet maintenance company, and then we have operations both in the Nordics and Baltic countries at the moment. And of course, our biggest customer is by far still the VR Group and its business operations, but we also have other customers, and we are in our strategy we're trying to extend our services also outside Finland at the moment. And here is the VR organization. So we have like 4 different business units: properties, VR Transpoint, which is the cargo operator, passenger services, and then VR Fleet Care. And we serve and offer all kinds of services: modernizing services, asset services, and component maintenance services, and then the smart care service portfolio is the one that I'm responsible for. And our approach about the digital development and digitalization is that we try to provide the whole value chain of the digital transformation, and we use selected partners that are basically equipment manufacturers. And then we use equipment manufacturers, and then we utilize our long experience in the railway industry, and also the expertise that we have to make the transformation. So, but now to the actual case that I was supposed to talk to you about. It's about as Daniel said, so about the intercity wagons, and then mainly the bogies. So those wagons that are in the picture, so they are basically the backbone of the passenger services and then passenger trains that in Finland. So we have approximately 300 of those kind of intercity passenger wagons, which are manufactured by Transtech, which is nowadays owned by Skoda. But they are anyway manufactured in Finland. And of course, the wheel sets and bogies are one of the most critical and most expensive system in the wagons. And at the moment, the change interval of the wheel sets is 900,000 kilometers, and bogies, it's about 3.3 million kilometers. And basically, we don't have any failures caused by wheels, bearings, or bogies. We have some single bearing warm bearings, mainly caused by too much lubrication or whatever, but basically no breakdowns. So that would say that we over maintain the bogies and wheel sets pretty much. So the question at hand was that what can be done to extend the maintenance interval and while keeping at least the current reliability level. So this is the problem that we wanted to solve. And we wanted to solve the problem with using IoT and also utilize our engineering and experience. So basically, what we did about the equipment. So to wheel sets, we used measurements for the wheel profiles and also the wheel bearing condition monitoring. So basically, we saw that the current profile that we had, or the old profile that we had in the wheel sets. So we knew that the wheel was wearing from the flank. So and the wheel did not, the wheel life cycle was not sufficient. So what we did, so that we changed the wheel profile into other kind of profile, and with that single change, we got an increase of 30% to the wheel life cycle. So then we know that the wheel should not be any more a problem. So the wheel would last a lot more than 900,000 kilometers. And to the bearing, so we use this kind of condition monitoring sensors, and that will enable safe extension of the bearing change interval, so that we know at least 3 months in advance that now there is something failing in the bearing and we should change it. So with these two measurements, we could extend the wheel set lifetime. And then on the bogie, so we have experience previously from bogies, and we know that the bogie condition can be monitored by following the running behavior of the bogie, so-called hunting effect. So basically we do that by measuring low frequency vibration of the bogie. So we attach those kind of vibration measurement devices on the bogie frame in the different places, and we know that when there is some change in the bogie running behavior, so we can then see it from that measurement signal. And we believe that with those kind of measurements we can find if there are any problems with wheels, about some errors in the functionality of springs or shock absorbers, and then if the rubber parts and their mechanical functionality will decrease. So we believe that all of those can be detected with one single measurement. But one of even more important thing is then the process and the safety, since we are the entity in control of maintenance of basically all the rail fleet in Finland. So we are therefore responsible for the safety and reliability of the whole rail fleet. So we have to be really careful in what kind of changes we are able to make. And then we actually started the change process already in the planning phase of the project. So before we had installed any sensors anywhere, so we started the change process, and so that we would enable a faster through time of the safety procedures and assessments. And also we discovered that there are changes needed in the production process. So those changes were mapped, and the cost and the effect of those were clarified. So for instance, we saw that the bogies are now maintained with the whole wagon. So if we want to increase the bogie maintenance interval, so we have to maintain the bogie separately from the wagon, and that will need other service track and service location, and that has to be taken into consideration. And also there is a change for our maintenance planners, because they have to do a lot more planning. So all of these things have to take into consideration. But then what are the benefits that we are looking for in this change? So the value of this kind of condition monitoring is what we are targeting, to extend the wheel per maintenance interval by even 67%. So at the moment we are targeting to get to the 1.5 million kilometers, and another target is to extend the bogie maintenance interval from 3.3 million to 4 million kilometers. And of course, when we're talking about condition-based maintenance, so the final result will depend on the life cycle of each independent bogie and wheel pair construction, so that the total value cannot be estimated in advance. But we have not found any specific factor at the moment that would disallow these goals, since we know that all the parts should last for these target values. And now that we are measuring the condition of those constructions and those parts, so we should be able to detect if there are any failures starting to form before they affect any or anything bad happens. But what is also something that I'd like you to consider, and what we have learned during this our 3-year journey, is that if you want to increase the return of investment, so you should start the measurement from the parts that are close to their maintenance interval. So if you install the equipment to those wheel sets that have been maintained recently, so basically you will have to measure or wait 2 to 3 years before the next maintenance interval cycle would come and happen. So basically, if you want to increase and decrease the time that you see the value, so if you start with those wheel sets that are really close to the 900,000 kilometers, so then you can actually start extending the interval from the first year on. So that's something that we have discovered and are trying to do now. And what's also one thing to consider is that if you want to increase additionally the return of investment, you should consider that you only equip a part of your fleet. So basically, we don't need to equip all 300 wagons and 2,500 wheel sets, because we believe that for the first 1 or 2 years, so you basically don't have any faults. So you probably will only need to equip those wheel sets that are really close to the 1 million kilometer interval. So basically, new or recently maintained parts, they probably do not need monitoring. So then you only have to buy like a part of the whole fleet and equip the only part of the fleet, and that will then of course save the money, and still you probably will have the same outcome. And then also, as I mentioned, the safety assessment. So if you want to decrease the implementation time, you should start the safety procedures and safety assessments and change process in a very early phase of your project, because we have found that that's something that is really time consuming. And that's of course has to be, you have to look very carefully about the safety, all safety related systems, and since bogies and wheel sets are really safety related, so you cannot take any risks there. And then of course we all know that there is some resistance to change in every organization, so we try to include all the parties that are affected to the change in the earliest phase. So we will try to let them be a part of the change and not just the target of the change, so that we have found that they are really they take the change much easier when they get to know about the change in a really early stage. And then the timeline of our project. So we actually started the project already in 2019, and we had our first test installations on wheel bearings and test measurements on bogie frames. And then this year we're trying to and deciding about the pilot. So next year we're gonna have the pilot with 30 wagons, and then we'll look at what the results are and refine the business case, and then hopefully we'll get the decision to extend to the whole fleet then in 2022. But this is maybe one of the biggest IoT cases in Finland at the moment, because this is the biggest passenger fleet that exists in Finland. So that was my presentation. Hopefully you got something out of it.
Well, certainly. Thank you, Mikko. I certainly did. It was very interesting indeed. Some of the things that particularly stood out, I'm quite encouraged to see the percentages of performance improvement that you're already witnessing. These are not small numbers, and it's an incredible achievement to be able to get those in this relatively short space of time. Obviously, you're focusing on the big, the big wins, let's say, early, and fascinating also to get that insight into the return on investment. And I appreciate your honesty or being so candid with us about this, because there's a very big clue here about in terms of how to go about these projects to demonstrate the value. And just to finish up on the last point that you made, which is to include domain experts or business people all the way through the process, and then there's a feeling of ownership, and that actually came out of our last discussion as well on the infrastructure side. So some really interesting points there, and I'm looking forward to picking up on some of those things in a bit more detail as we move into the discussion. But thanks for now, and we'll catch up again in a little while. Okay,
thank you. Yes, we do.
Thank you. So now we turn our attention to deployment strategy and to IoT architecture that's required to achieve operational and maintenance goals. So we're going to find out a little bit about what this architecture might look like in order to enable the right data to be acquired and the analytics to be leveraged effectively for cost saving and new business models. I'm happy to see that all the speakers have mentioned new business processes or business models, and I'm looking forward to hearing the next speaker build on this. And so without further ado, I'd like to welcome to the discussion from Stimio, the founder and CEO, Mr. David Doval. Welcome, David, and I look forward to hearing your presentation. Thank you.
Thank you, Dan, for introducing me, and thank you, Ben, for organizing this good event, even if it's a special condition with the COVID. So, as you told, Dan, I will try to make an example of what we have done with our IoT. We are IoT companies that manufacture, design IoTs, and our deployment strategy, which can be intelligent, improve significantly the operational and maintenance cost. So my name is, does it work? So my name is David Doval. I'm the founder and managing director of Stimio. It's a French company of 30 people that design IoT for the railway and infrastructure market. So we'll do that in a quick overview first. Then I will try to explain you why railway and IoT is a perfect match from our perspective as IoT experts. And then we'll see an IoT journey in passenger train and how we start from a small use cases and extend it to many use cases, now up to 23 use cases with the same architecture. And I will end up with the AI and IoT and how we can leverage IoT data by AI within the device. before concluding my speech. So Steamio is a IoT company of engineers, and we design and provide energy autonomous IoT. That autonomous is very important. Solutions that are made of modular hardware, embedded software, wireless transmission thanks to new radio protocols, and data services for the rail and infrastructure industry. So we came from the left part of the slide, so the hardware. This is really our roots. We are all people here are electronic engineer or software engineers, and we focused first on creating a modular solution for data generation. So it was designed in a modular way, so we can measure temperature, pressure, vibration, many parameters, position, strain, and so on, with one single modular hardware. Okay, we did so because we believe that AI that will come soon in the object needs kind of modular approach. We also take in charge the data transport from after acquiring the data, we transport it to the cloud through various means that are mainly radio, low power radio, to extend the autonomy of our devices, and with the aim of being agnostic on this and deliver the best protocol and radio solution to serve the use case. And finally, once the data are transported, they are exposed in the cloud, where we offer, but it's really optional, visualization and tools, and also all the health report from the fleet that is deployed on the field, as well as services around device management for firmware update, edge intelligence, and so on. And our goal is to give our customer data that are then used for example, for operators or train manufacturers. And we want to give data that are useful for the business application. So IoT can be considered as the perfect match for the railway industry because it's capable of measuring for years some small data, and railways industry is often made of very old rolling stock and that have been designed even before IoT was invented. 10 years ago, nobody talked about low power radio. Power consumption of edge devices was so huge that it was impossible to have IoT running for more than a few months. And in the last 10 years, the semiconductor industry has changed everything, and you can see it in your phones. And now it's capable of measuring things for years. And moreover, IoT allow also to have continuous and real-time monitoring and computing on the edge within the device allow to just inform and alert when needed. And the last but not least is that the IoT, which are autonomous, allows easy retrofit with a no cable approach. I mean you can take an IoT with a battery for 5 years, and you don't need to put a cable within the train, and you can get the data with a low power radio. And if you look at the train, so there is many locations within the train where you can put IoT. It can go to the pantograph, where you can measure, for example, the uplift time and see if something is wearing out or not. We can monitor the door and the air pressure and all kind of levels from the oil, the batteries, the water, the sand, and as well the monitoring the compressor or wheel flange lubrication. IoT can also survey indirectly the tracks thanks to sensor put on the frame of the train, but looking for each defect on the tracks. And we have a project in this. And we also can survey the air brake system, for example. So this is really a domain where one sensor architecture can cover many, many use cases. And because of the qualification, certification issue, or and duration within the rail industry, it's very good to have a generic approach where one system can cover many use cases. So concerning what we have done in the past and where we are doing what we are doing today, I will try to tell you a story that is a journey in a passenger train. So in fact, the first project we had in this railway industry was concerning the toilets, and our customers say how we can improve the comfort of passengers simply by having toilets available and operational. So how to better manage tanks of clean of brown water, how to empty them, how to fill them, how to make sure that when the train is starting, all the toilets are operational, and when and how to deal with the subcontractors so that they just fill what they need to fill and empty what they need to empty. So it's a basic approach, and but it's very powerful and very useful for the passengers. So the solution that was designed was an autonomous IoT system, which is certified for the railways industry. And so this product, which is shown on the bottom, is installed in the tank, measure the level of water, has 5 years of autonomy, is communicating by radio to the either to operating network or to an internal gateway, and is made of sensor system. It's not one sensor, it's a set of sensors, so that we can reinforce the level of confidence when we detect something. And most importantly, it's based on a modular architecture. So with this type of sensor, we are able to monitor the level. But for example, the level of water, you have to monitor it and measure it only when the train is stopped. Because on the move, you can have some side effects and the level is not stable. So one challenge was to detect the stop of the train. And it has been developed, and we do it within the device so that we are totally independent and we can do it without having the GPS and so on. And at the end of the project, what we have a modular architecture, which is installed in the train. We have gateway, so which means that we have created a backbone in the train that can also accept other type of sensor for other use cases. So once the toilet system was in place, it's natural for the customer to extend the use cases with the same architecture. The sensor was qualified, the gateway were installed, so we could address other use cases without recertification and without requalification of the device. With an existing backbone, and thus the ROI of next use cases were much faster than the first one. And we are also so what we did is that we developed another type of firmware or software within the device that also that already has some sensor, and we address wheel set lubrication and for example pantograph uplift also. And this is something that is deployed on 20 use case now. It goes from battery level, door closing, lubrication, levels, and so on. And you just have one device covering many, many use cases. So the saving and ROI, I'm not an expert in the rail maintenance, but what we have learned is that the savings was related to the field operation. So it's less time to identify the issue, less people to send to fix a problem, and you can repair on site or fix it on site, or if in case of water tank, it's just know what tanks to fill in first. From a maintenance perspective, you as mentioned by Miko, and you switch from I would say preventive maintenance and systematic maintenance to a condition-based and even a prescriptive maintenance, where you have more data saying, okay, it's the decision is based on this and these parameters. And from the ROI related to the use cases were estimated to 12 to 30 months, depending on the use case. And we expect, or what our customer says and literature says, that IoT can reduce maintenance by 20%. And the challenge of having more trains more often on safer networks could be helped by the IoTs. And there is another type of gain, that is a risk avoidance, and to avoid that avoids collateral damage and traffic stops. For example, a catenary that is broken by a pantograph could disturb the traffic heavily, and the damage, the consequences are very costly. It's about 200K per event, and it's about 5% of locomotive have a catenary issue each year. So this is typically hard to evaluate, but the risk avoidance is probably one of the most promising things for the IoT. So you know well before an issue can arise. And it's often at the interface of the train and the infrastructure. So I just want to give you a few words about IoT and AI, the next frontier. As of now, artificial intelligence is often done into the cloud. And what we have developed in Steamio is that we have a system where we put some data, we analyze data in the cloud, and then we create some algorithms that are put into the device, edge device, so that you make the edge device more intelligent and more autonomous. So you save you save autonomy, and so you have a better reactivity. You don't rely on a network, and you can work offline. So it's really something that is very promising with the first approach we have. And my conclusion is that even big data is not really IoT, because IoT generates a small amount of data, but the sum of IoT is big data. And this is what is important here. And the retrofit of trains with IoT autonomous system is very easy and leads to a low total cost of ownership. And you can have a progressive approach. You can start small, and then if your system is well designed, you can really have a use case by use case, have a very well equipped train. Every gauge here that exists in a train is an IoT candidate, because IoT can be also considered as making existing gauge communicating. AI at node and edge level is already possible, but it requires that you have a first phase of analytics on the cloud. And we also believe in Steamio that train to infrastructure monitoring is a very promising field where our approach can bring value to the interface between the tracks and the wheel set and the pantograph and the catenary. So thank you for your attention, and we will also participate to the next event in November in Scandinavian Rail, and also next year in Köln with Ben organization. Thank you very much.
So David, thanks so much for your interesting presentation. It was fantastic to get a dive into the passenger side of IoT there, and yeah, it's clear that you've made some fantastic improvements and developments, and some great discoveries along the way. I particularly like the fact that you raised this topic of edge computing. It's an interesting, let's say, discussion between, processing in the cloud or processing on the edge. Depends obviously on lots of parameters like power and what kind of applications you want to accomplish. But I think your insight into the entry point that you found in terms of this passenger comfort and the humble toilet, and how that actually unlocks the door, because once you've got the gateway, then you can actually justify evaluating and testing further use cases quite quickly, because the base infrastructure is there and it's agnostic and so on. So there's going to be some great topics to discuss later as well. I think particularly about the sort of your experience in how to quickly scale up on the passenger side is particularly relevant. So we're going to move on, guys. So we'll catch up with you later, David, but we're going to move on now with our next speaker. I've known our next speaker for a number of years, and he's always very passionate, I've got to say, in driving the value in digital solutions, and also thinking broadly about leveraging the data to make both rapid IoT impacts, but also in addressing some of the, let's say, the insights or the opportunities for partners and for the wider community and ecosystem. So welcome to the webcam, without further ado, the Head of Innovation Management from Rail Cargo Group, based in Austria, I believe, Mr. Martin Zivkovic. And that's a great name to say. I've learned over a few years how to say your family name. Still haven't quite got it right, but I'm from Manchester, so Anyway, I'll leave it with you.
Thank you so much, Daniel. Well, as already heard, my name is Martin Zivkovic. I'm Head of Innovation Management at the Rail Cargo Group. And currently, we are working on the implementation of the innovative freight train and the preparation of the next step, which is the intelligent freight train altogether. What I want to present today is our main IoT project in this domain of the innovative freight car, which is smart cargo. I want to give you a brief introduction on the project, on the key points, but then I would like to take the time to show you what we did besides the main path. So I want to show you the basic architecture and what we were planning, and then which opportunities came up, so in terms of efficiency increase, in terms of new business models, insights, etc. So this is what I want to do in the next 13 minutes, and then I'm looking forward to a fruitful discussion afterwards. So what we're doing in this project is basically equipping our wagon fleet with IoT trackers, GPS devices, and additionally, we're developing an IoT platform where we don't want only to include our own wagon fleet, but also other wagon if we rent them or whatever, and also other IoT data, let's say from infrastructure, etc. The most important thing is that we want to apply this data in various systems and processes, just like the inventory systems. And besides this, we are also testing various additional sensors to this main GPS unit, because every fleet has some other specialities where we need, for example, the weight of the wagon, the weight of the loading, where we need door sensors in order to know when the doors are open, perhaps if there's some theft. We're attaching very similar sensors also to containers, and all those are like pilot projects that are that we're running in this main smart cargo project. And of course, we are also planning the equipment, like already said, of containers or of our wagon fleet at Rail Cargo Hungary and others. Well, the basic architecture, IoT architecture, is that we have a unit that is attached to our wagon, and this unit sends data to the IoT backend. And in theory, you would say then this data is shown to the user, to the fleet management team, etc. You might have already the feeling or ask yourself why I'm saying in theory, because what I want to show you in this talk is that raw data is already very valuable and of interest, but what you can make out of this data with interpretation, with machine learning algorithms, etc., that's where the real value is inside, and that's what we're doing together with our partners. And that's what I want to show you now. So basically, as already said, we have this main GPS unit, the IoT unit, that sends data every 15 minutes, and it's, you know, it's taking GPS data, it's taking motion and shock sensors. We have an integrated temperature sensor, and all this data is coming in 15 minutes interval in our backend system. So showing this data only to our wagon fleet managers, to our customers, is, as already said, of value, because we know where the wagon is in almost real time. We know where it's moving to, or whether it's standing for quite long. And from this point of view, I could end an IoT presentation with this slide. So this is kind of what we were asked to do, and what the main purpose was, to visualize in real time where the fleet is. And then we were discussing, well, there is more. So the first question is, and then we were asking ourselves, is it really, for example, the shock that we want to know? Or what is the information that we want to gain out of this? And well, the next slide shows, well, actually, I don't want to really know where a shock was measured, but I want to know where damage is caused to my asset, to my IoT device, but also to the wagon itself. So right now, on average, we're getting kind of 50,000 shocks per month. There we have a tremendous information overflow problem. So we cannot, you know, if you give this data, as we've seen on the chart before, to the user, he or she, they cannot do anything out of this. So what we need is some intelligence. What we need are algorithms, machine learning, in order to use this data and in order to create real value. So what we started to do is we took the shock data that we were getting while a wagon is standing still. And then we applied some machine learning algorithms. So not we as Rail Cargo, but our partners from A1 Digital, or together with our expertise. And what we found is that we have a very high fit on whether a shock is causing real damage to a wagon or not. So this is something where we had a real starting point where we said, this is of tremendous value to us. So the next question was, if I can measure the damage to the wagon, could I measure damage? So could I interpret damage towards, well, might it cause damage to my, not only to the wagon, but also to the loading or not? And this is the next thing that we would like to test. So the next thing was, where can we add additional value? So what we know is that weather forecasts and weather data are of high importance for predictions, for forecasts, and for plannings in rail freight, where we found, well, actually, we already have 8,000 weather stations, mobile weather stations going through Europe. So again, additional value. it became really interesting when we had a look on garbage data. So as already said in the first analysis, where we wanted to know which shock might cause damage to the wagon, I'm sorry, we were only taking the shock data from wagons standing still. So what about the rest? So we were just playing around with our partners and got, for example, this graph here. So what you can see is the heat map of some special track where we see that in a very short period of time, we had a lot of shocks. And so all on the front, on the side, and up. So what we did is we went to the fleet experts and asked, how is it possible that on an open track, you would get in such a short time from such a small sample size, such a tremendous number of shocks? So the conclusion was there's a shunting yard and they are not coupling the wagons short enough. And as this track is kind of hilly, you would get this shock picture. So we had the opportunity to just contact those people from the shunting yard and say, hey, what is going on there? So can we change the process, or could you train your employees better, because this is a very outstanding situation. And so until now, we were just working with the first data sample and we are going to extend it now. But what I could imagine is that this happens not always, but only in some periods of time. So you could know not only in which shunting yards does it tend to happen, but also is it only a special shift, only the night shift where it happens? Is it only in winter or in summer where those effects happen? And this will help us so much to increase our efficiency, to improve our operations in various fields. The next thing that we found, again from, I'm calling it garbage data because it was no primary data that we wanted or that we were asking for, but just being curious, when already talking about shunting, well, what happens in shunting yards? And all of a sudden you can find clusters, and we have shunting yards where the probability of getting a shock is above 80%, 81%. And you go a couple of kilometers southwest, and the probability, or northeast, and the probability of getting a shock is 9%. So of course, what we found is that the shocks are not really problematic, and that you have infrastructural differences that can explain this difference. But again, what you might do is go to the next analysis where you're saying, okay, well then just compare those clusters that are also from the infrastructure side comparable, or others. So as you can see, there is so much that you can gain, that you can learn, and also we can rethink the business models that we have, because if we're combining, and if we're just taking data that is accessibly on the internet, so geodata, like we have our own weather data, but you could improve it with humidity, etc., etc. So there's another very easy example that I would like to mention in the end of my presentation. Sometimes it happens that stones that you would transport freeze, and you cannot unload those small stones. And this is a problem, because whenever you open the system in order to empty the wagon, you must not move it anymore. So if the stones are frozen in there, you have to wait for some time. Well, it's super easy just using the weather data that you have. So the sensor might measure humidity, but it's the box is closed. So we are using official open source data for humidity. We have our own temperature data. We just applied a very small model in order to learn which combination of humidity and temperature leads to frozen stones on the wagon. And we kind of eliminated this problem very quickly. So also we did a very quick and dirty approach we're just sending text messages to the ones that might unload the wagon and informing them that they shouldn't, just because the probability is pretty high that the load is frozen. So this is what we're doing in our smart cargo project, basically. So I mean, what I was presenting is where did we start? What was the task that we had? And what are the first things that we could realize with a bit of creativity and data science?
Thanks, Martin. Really interesting presentation, very punctual. That keeps us on track for the discussion as well. So thanks for that. Obviously, lots of things that are interesting to pick up on. I think particularly your experience of the journey in terms of, you know, this sort of going from device to data to insights to processors, but also, you know, actually sometimes something that we've noticed is that you've got to look to the side or laterally to where your initial interest was, and you called it, I'm not sure what you called it, but something the data pool or whatever, yeah, something like this data that you're not actually expecting anything to come out of, but with a bit of sort of a domain knowledge and an appetite to discover what's going on behind that data, you can discover some incredibly interesting and valuable things. It actually reminded me of another use case that you know, we've been looking at in the petrochemical industry, where crude oil can't be unloaded in certain temperature ranges, and obviously this could create a huge issue because you've got lots of wagons all backing up that can't unload, and there's knock-on effects. So I think that, you know, when we look at the different speakers that have mentioned, you know, sort of you know, where they found the value so far, one of the recurring themes is, you know, to look laterally, but also to consider the integrated approach on the data. And you finished up with bringing in the weather APIs and the conditions on the humidity there, something very interesting to explore further as well. So we'll say goodbye for now, Martin. I'm going to welcome the next speaker to the session. It's actually our final speaker of today's session. We're going to hear from a technology vendor now. This is a company that's not exclusively in rail, but focuses on gathering data and delivering platform-based solutions in multiple verticals. But, you know, extending that theme again in terms of, you know, how can we look laterally and how can we build in different APIs and different pieces of information to improve our performance. We're going to discover how predictive we can now be, and also to discuss the democratization of data and how business users can evolve their understanding and control. So it's about sensors and hardware and about predictive applications. I extend a very warm welcome to the Director of Vertical Market Solutions from A1 Digital, Mr. Francis Separo. Welcome.
Thanks, Daniel. I appreciate the invitation, and thanks, Ben, for the organization. Can you hear me well? Okay, so a little bit about A1 Digital. I have the privilege to lead a team of great, crazy people, all focused on innovation. And what we do is basically four things at A1 Digital. Number one, cloud. So we have our own cloud, which is a European cloud, not linked to Amazon, Microsoft, or the other American-based clouds. We take a very strong position on data sovereignty and other topics. We are part of the A1 Group, which is the telco telco in Austria and in many other Central and Eastern European countries, and we are part of the America Mobile Group. Now, cloud, IoT, advanced analytics, and security, these are the things that we do. These are the basics of our complete technology portfolio. We have over 600 customers, a little bit more than 600 customers right now. And we operate in more focused on the DACH region. So DACH being Germany, Austria, and Switzerland, but also with customers all over the world as we provide worldwide connectivity. So that's we are around 200 people, and that's basically what we do. Now, what we are speaking today about is about the predictive applications, and I would like to go step by step with you through the processes of, you know, debunking some myths around predictive application, discussing the future of predictive applications in general and giving you an overview of what we've done or what we are currently working on actually in the area of predictive applications. So one of the things that we are discussing today with our clients and partners is what is a predictive application actually. So how can we talk about a predictive application without a definition? So we came up with this definition, which is it's a business application first and foremost, which applies data techniques, data mining, predictive modeling to analyze data and to make predictions about the future or unknown events. So with that, it's very clear that flipping a coin or using a crystal ball does not qualify as a predictive application. One of the myths that we have around the predictive application area is that you need insane amounts of data to run predictions, that you will need to use neural networks, and that you need a lot of data scientists, and that it will never pay back. None of this is real. In reality, you don't need insane amounts of data to run predictive applications. Neural networks are not the best algorithms to uncover patterns in industrial data at all. They perform actually pretty poor compared with other algorithms, and there is a scientific demonstration on that, and we have run a couple of tests to prove exactly this. We don't appreciate having an army of data scientists. We simply don't have them, and we don't believe that our clients, partners will ever get them. So what we do instead is we use platforms that augment the performance and the capacity of data scientists. We still need data scientists, of course, but these are platforms that are more located towards augmenting the capabilities, let me put it this way, the capabilities of business teams and in partnership with data scientists. So data science is a teamwork. Without subject matter experts, you will never get to any meaningful results in data science. The second thing, around that it will never pay back, we know exactly that is not true. We've seen dramatic improvements in business performance out of predictions, and I think all the speakers before highlighted exactly this. Now, it's not a simple thing, obviously not, and it requires a lot of work, and I want to give you just a sneak preview behind the curtains so that you can see really what does it mean, what are the real topics to be discussed there. And it's not a low maintenance business, obviously not. You require platforms, you require a certain level of knowledge and certain level of resources, and that you want to keep under control. So moving forward here, and demystifying a little bit predictive applications, what happens? What you have is a loop basically, and that loop goes from collecting data, from understanding the data, modeling, and to productive deployment. When you're dealing with data, you have something very specific, which is data is a 4C problem, actually. So data has to be complete, has to be correct, has to be consistent, and has to be contextual. And that's absolutely relevant. And you need to be able to collect the right level of data in order to move forward in this type of projects. Another thing that happens is that data doesn't come ready for machine learning. It's not true. So none of the systems that we know of produce data which is machine learning ready. So you have to transform the data, you have to denormalize, aggregate. When you do modeling, for example, you never have the right level of features, or normally you don't. So you have to add features to that. You need to do model generation. And once you generate a model, you need to take care of uncovering what we call anomalies, model drifts, and phase shifts in the data, which is basically fundamental ways of understanding if the model is still performing the way it has to perform based on the training data that you had before. And then you have a whole conglomerate of issues around deploying models into production. You need to have very solid IT platforms that will allow you to deploy the model into production, and that's why we use platforms that are already ready-made to operate in a cloud environment in auto-scalable and auto-deployable fashion. One thing that is also important is to understand that you will take predictions as first-level citizens into deriving additional insights ahead of the curve. What I mean by that is that you will take the predictions from one system and use it as inputs into another system, so that you can take from here, you can create a system of decision-making support that allows you to look into the future and not just looking into the past and obtain data from there. What you see on the right here is a very simple model decision tree that was used to create a predictive maintenance calendar, you can trust me, the amount of data used to create this predictive maintenance calendar was 15 megabytes, not more. We didn't need any byte or bit of data additional to that. And it's a 5-step loop. What it means is collect data, understand data, model data, deploy into production, and repeat. So it's an iteration is super important here. I think Martin already mentioned that. We had the privilege to work with Martin, who's a great innovator and is keeping us awake at night with a lot of questions, and thanks Martin for that. What we developed together with our partner Cargomon was we developed one platform, and I'll be talking about platforms for a couple of minutes in the next slide, which is we believe in platforms. We believe in hardware platforms and we believe in software platforms. That means we want to have one device that has an extended battery life, is completely autonomous, it has a set of sensors, but also can connect to additional sensors that might be put in connecting range from that device. So as we have the temperature sensors, the GPS, and the accelerometers, that's all good. And with that, we've done certain interesting work. However, what we believe is that having the Bluetooth that connects this device to other sensors is where really you have a lot of versatility in the device. And that's what we want to create here as well. When you look at the software side of things and then the system side of things, then you will have basically 5 levels of predictive applications. The first one is where you prepare for business impacts. You have there you select your pilot use cases, you select your partners, you select you align on the platforms, you run the first POCs. That's great. So that's where we believe we've all been, and our clients and partners have been as well. The second level is the level of subsystems. Here, what happens is that you look at the predictive analytics at the level of detecting wheel bearing damage, flat spots, weight detection. So what shocks, filter, not the right performance on the exhaust filter, pantograph, and so on. So these are subsystems of a complete asset. Then you look at the assets from the asset management perspective, and you have there is very important to detect anomalies and combine with additional asset data and have predictive maintenance at the fleet management level, which is the next thing that you will do, understanding how can you use multimodal logistics and predictions for that, how to use predictions for optimizing shifts, for optimizing call centers, optimizing secondary infrastructure. And then the last but not least will be obviously the ability to include strategic management decisions based on performance predictions on macroeconomic or microeconomic cycles, strategic decision support systems that will include specific risks and additional topics that will be associated with data and insights that you discover out of this data. Now, for this to work, you obviously have to have your enterprise systems. And I think the speakers before, Garrett, was alluding to having its own IT. And yes, of course, you have your ERP systems, your data warehouses, supply chain management, and many other systems. However, those systems are not designed and were never designed to be predictive systems. There is no predictions running on those systems at the moment. What you need also is to you need to have an additional layer, and that layer, that platform layer, is what we call the business process management platform. There we have a partner from Corporate is our partner for that, and there our clients locate their strategic initiatives, balance scorecards, quality control programs, PDCA, Deming cycles, operations management. There you have the full focus on what is driving the business, transforming the business, and you combine that obviously with the enterprise data. Then you go further and then collect obviously this element, which is super important. There's a machine learning platform that allows you to interpret your models, to collect the data, the sources, things that you will get from the IoT platform, where you have storage and real-time analytics, only when you have these three elements linked into your enterprise architecture, then you have the ability to create what we called platform-based predictive applications. And why are platform-based predictive applications so important is because if you go the other way, which is going point-by-point solutions, you potentially will kill the whole initiative because of integration costs and because of vendor lock-in. What we want to do is enable and empower our clients to make sure that they have a sustainable and repeatable impact at a low cost, and they can achieve the economies of scale that the economies that platform-based applications bring, which is economies of scale, economies of scope, and economies of skills. And that's what's very important. Once your people learn to work on these platforms, they can be self-sufficient, and the productivity goes into very high levels. And that's super important. So if there is one message that I would like you to take out of these slides is predictive analytics, the future, and as we're doing it today, it goes through platform-based predictive modeling and predictive applications. If we look to the next level, the combination of what is happening in the present today, I would like to guide you very quickly through a couple of real-life scenarios where predictive applications have been developed, and you can have a look into them, and then we can discuss later on. We'll start from the top. So we will discuss basically the management decision support systems where predictions can be used for driving and getting better insights at the management level. So one of the things is obviously having a managerial decision support system. What happens here is that you have data and you have planning, and all of this needs to happen in a business context. All of this needs to happen into a context that allows for business execution. That means project management, initiative management, and where there is measurable, very important word here, measurable business impact. So how can prediction play into this game? So for example, if you have here, you see here a classic PDCA, plan, do, check, act. This is the Deming improvement cycle. And how can you make it really, basically predictive? Well, basically out of the data that you collect already, risks can be identified that you will never see without having the proper data. So human intelligence is not enough to analyze all the risks. So for example, if you have problems with specific usage patterns that you can only detect when you have predictive analytics, you can add them here into this risk analysis. So it's an augmentation of your ability to address risks. You have the fishbone diagram for other topics. I see Daniel already, so I'll speed up a little bit. And then you can analyze the impact here. What you can also do is, for example, move into another layer, which is the layer of logistics planning and simulation. And I'll leave this on the slides. You can have a look into that. Here we integrate IoT data into the predictive logistics platforms, and with that you can circle very quickly into multimodal simulation. Next topic, I'll be very quick on this one. This is something we did for call centers. I'll leave it. And then predictive maintenance calendar application. This is very simple, extracting data from your enterprise asset management and moving up the ladder into predictive maintenance models so that you have a maintenance calendar, a proper maintenance calendar for your assets. And it's not only the railway freight cars, but also any other type of machinery. Let me move to this one. So you saw this picture from Martin, and behind this picture, what is behind this picture? Behind this picture is a lot of data that we collected, 150 models that were tested, and you should not try this at home. It's really a lot of work. And the best model was selected to analyze what kind of shocks are we having into the on the assets, right? Then if you look then at the edge level, and I'm finishing here on this one, and then one exercise that I want to give you for the weekend is if you have a flat spot detection, you need to do it on the edge. You cannot do it on cloud-based analytics because the data transmissions cost will kill the whole business case. So that's what we did then with this device. We equipped this device with machine learning capabilities. How we did this was basically creating models based on data that we collected, putting these models into the microprocessor within the device, and then being able to detect single events, flat spot warning, and probability of wear and tear into this device. For next week, I'm going to give you one exercise. This is the last slide, which is try to brainstorm some predictive use cases, try to get some ideas around what will be the potential outcome of this, get first offers for POCs. And the second exercise is very simple. Visualize your competitor completing this exercise ahead of you. And I think you will have a lot of motivation to move forward in this direction. So thank you very much for your attention.
Francis, thanks so much. It was coming thick and fast, but really fascinating stuff. And you know, I'd like to say particularly interesting to take a look behind this curtain that you described as well, because you know, I think that this idea of you know, how do you extract? Well, first of all, everyone knows that we need to collect the data, but then to understand, to model, and to deploy, and what's actually involved in this. And you know, you bring in the mention of you know, a fusion of 3 models at the end there. You know, it's not child's play, but at the same time, you know, with a sensible approach, and by including, like you said, the knowledge of the domain experts and so on, and building that into the you know, sort of the data team, let's call it that. You know, you can get some really big value out. And I'm very happy to see that you brought in the digital twin as well, because you know, this is a subject close to my heart as well. And you know, maybe we can go into that a little bit more as we go through the discussion. We have some questions from the audience, and if I could ask everybody from the panel to join us again, we can get straight into those things. So welcome back, guys. It's good to see that you're all still here. It's good to see that Miko's still got the sunshine with him, obviously at those northerly latitudes. I think we're going to hit off, you know, with some questions from the audience to begin with, and we'll see, you know, how that works out. I've got a few questions and themes of my own as well. So there's actually a question here. Can somebody please comment on the value of historical information versus the value of real-time new information for maintenance? Now, it's quite a generic question, but I quite like that as well, because you know, obviously everyone's going to have a slightly different perspective on that. Francis has just touched on it, you know, in terms of everybody's talked about historical and real-time. Maybe Gerrit, could you have a first hit at that one?
So the value of historical data combined or compared to live data, or?
Yeah, I mean, we're talking about, you know, historical or even API related data. Let's extend it to that, you know, from third parties and so on. We heard Martin mention about the weather data, the humidity and so on. You know, are there other examples that we can refer to here from different experiences?
I think it's different streams. The users that today are looking for live data in the systems to do a live job to improve our operation processes, they are usually not interested in looking back on data for maintenance or analytics data for transport streams and services that we have designed. And from my perspective, the low-hanging fruits is using the live data, because this is something that we do not yet have. Or in many places within our organization, we do not have this live data. But when your organization matures over the time, and you also get ready for using larger amounts of data that are from the past and that you can analyze, that you can visualize with analytics tools, and you get ready for that. And our customers internally as externally are demanding those insights. So yes, I think there's value, and we're up and running, exploring this value.
It's interesting to see that everybody's been talking today about the processes and how we can improve processes and so on. Just on this topic of live data versus historical data, has anybody got a contrasting opinion or something else they'd like to add on that before we move on to another question?
Yeah, so I mean, I agree that there's a lot of interest in live data, especially on the current status of your wagon, etc. But I think that very often that if we want to understand and interpret live data, I need some history to understand what this means. So that is very simple to my example with the shocks. So I might measure a shock. And if I have a history where I know, okay, at this location, those shocks occur very often. And at this location, I very often have problems with my freight cars. So then I could get a feeling that the probability is higher, that this shock might be problematic. And if I then apply machine learning algorithms to train on this test data and on this historic data, but that's only one example. I think like the average wagon fleet in Europe is more than 30 years. So all the historic data that I have on the wagon, on what happened to the wagon, on the mileage the wagon did before, on the maintenance intervals, will help me to understand and to predict. That's at least my opinion.
I can give you a few words also, because if you talk about data, you have to separate what are event data like shocks, or normal data like humidity, temperature, or environmental data. And for the first event data, you cannot reduce them, because if you want to know, you have to transmit them and you have to acquire them live, and you cannot use them to historically predict what happened. And for the other data, it's a bit different, because you first need to gather data and model them and do some machine learning algorithm in the cloud, and then you can set the right level of measurements without sending too many data too often. And so what we are trying to do on our side is that we separate what we call trigger data and normal data, and that and you cannot have the same strategy for both data. Once is trigger data are here to detect events and to send alerts to people, and the other data are more used for modeling and so on. So this is two types of approach, and that's the first thing. And the second thing is that you need to have the ability to update the way you measure once deployed in the field. And for us, it's very important that once it's deployed, it's not fixed. You can change the way you measure, you can change the frequency, you measure the level, and so on. And that's a part of device management, which is a very important tool for collecting the right number of data.
Any comments from you, Francis?
I think it's important. So from our perspective, we believe in this 4C, what I was mentioning. The contextuality of the data, the completeness. So if you have the data in context and you can keep the data in context, it makes a lot of sense. Now, if your context is changing the whole time, then data becomes completely irrelevant. You cannot reuse that data. And it is super important what Martin was saying. If you have your data from your enterprise systems, you know that this wagon, this freight car, this wheel, whatever it is, this asset was already maintained certain number of times, then you know exactly that your data, the historic data that you have, needs to be put in context, because with every maintenance, for example, when you change, when you do software updates, or maybe you do some sensors updates, or you update the firmware of the sensor, the context of this data changes, and so you need to adapt your model to reflect the changes of this data that is coming in. And you need to have your models being robust enough and to understand that the data coming in right now is a different type of data, and how to adjust to this. And that's why it's super important to work very closely with it's team sports. It's pure team sports. We don't know enough about the assets. We don't know enough about maintenance, but maybe a data scientist can build robust models that will react to that.
And one of the things that I totally agree with you, Francis, and one of the things that I've noticed in our own experience is this, let's say, incorporating context from wherever is possible, and particularly from the domain experts, people who understand instinctively things that are going on in the business, but they've not until now been able to demonstrate it with data or prove it or actually, you know, address it with data. Now, Mikko, let's go to you for a second. You're obviously running your operation in quite unique sets of circumstances. We have unique weather conditions. We've got unique topography. You're transporting a lot of forestry goods and things like this. So, you know, how is this affecting the way that you go about deploying your IoT solutions and looking at the use cases?
Well, of course, we have a lot of temperature changes, so we have a lot of snow and a lot of ice and then cold in winter. So that's something that we have to take into consideration. But other than that, so I don't see that it should be that different from the others. But when it comes to the question of live data versus historical data, so maybe my opinion is that it depends on the case a lot. If you have a really an easy model, or since we're trying to look for failures from with the measurement, so if the failure can be detected really easily, so that you don't need any sophisticated mathematical models, so then you're maybe don't need that much historical data. So if you have a flat spot in the wheel, so the flat spot can be detected really easily. You don't have to do really sophisticated models. So then you don't need that much historical data either. But if the failure is not that easily detected, so then you probably will have to have historical data where there are those incidents also existing, that you know that in this wagon something happened that day, and then this is the data that has come out of that. So you have to have those kind of incidents to be able to make the model. So it's really depends on the case.
Yeah, makes sense. So you know, maybe just to there's some more specific questions from the audience here. So this is from somebody called Andy from RB Rail. He says, how do you ensure vendor independence, ensuring any IoT big data systems are not locked into one particular supplier? And this is something that has been mentioned by a couple of you, I think. I think it's an interesting topic. Obviously, it's about ownership of data. It's about can we trust the data? It's about who can we share the data with? At what point does the data become not the data in terms of extracted findings and so on? You know, maybe Gerrit, again, if you could maybe tackle that one first. Is that okay?
I think this is a very interesting question, and I cannot say that I have all the answers to this, because I think that the whole industry is still very much in a learning process. But when we talk about vendor lock-in, we start with using different suppliers or several suppliers for hardware and for data analysis, and also for the IT development. So we are equipping our fleet with 3 different suppliers of hardware, just to keep the market vivid and to reduce the impacts in our organization, our rollout, when one of these suppliers struggles. And also with IT development, we look for different suppliers to don't run into vendor lock-in and don't lose all the knowledge when one of the suppliers fails or breaks down, whatever. And we've seen all of that. So for now, I think we're going good with this strategy. And based on the ownership of data, this is something we discuss very actively with our customers and with our partners, and also with our lawyers. And DB Group is very actively pushing let's say the industry into those discussions, because many customers or also partners are they did not yet think about it, and if they did, they are maybe afraid of what could happen with the data. But what I've learned and what we see with our sales guys, that the discussion and the dialogue about this topic is so important, and it really helps to see what are the your objections and your ideas on this, to get to a common view. And I think when you want to make use of digitization and IoT, then you have to be open at least for the discussion. And most of our customers and partners are following this idea.
I mean, as asset owners, obviously the asset owner is in a unique position because they own the asset, they can equip the asset with the hardware, yeah? So this changes their opportunity, or you guys are moving up the food chain, let's say, in the value chain, yeah? How do you see this, Mikko, in terms of ownership of data and sharing data and so on?
Yeah, that's a good question. We think that all the data ownership is with the fleet owner. So all of our customers, the fleet owners, so they of course want to own the data. And I'm not jealous about owning the data. I just want to get access to the data, and that's basically all the things that we need. We don't need to own the data. We just need to get the access to the data. And how we have approached the vendor lock situations is that we try to choose our partners so that they are strategically important to us and we are important to them, so that will decrease the possibility of vendor locks. But of course they cannot always be avoided totally, but you can decrease the risk.
Yeah, I mean, we've talked about this many times, haven't we, Martin? It's a long process. It's a relationship. It's iterative. You know, you have to start somewhere and you make discoveries, and that gives you clues, and then you go and dive in there. And almost it gets to the point, and I guess, you know, Francis summarized this very nicely with his discussion or points about preparing for business for impact, subsystems, then the asset management, then the operations, and then the strategic. There's all these different layers. There's possibility for different requirements from partners, from domain experts, etc. Any comments on this topic, Francis? Because you're, you know, well and truly involved in this this topic.
So, thank you, Daniel. So, from our side, we fundamentally believe, and I personally believe as well, the data of our customers and clients is the data of our customers and clients, and that's sacred. So we have no intention whatsoever to have any access to this data which is not relevant for deriving more insights, right? So we have no questions about the data. The second thing that is important is we, and maybe, you know, as a systems integrator and I kind of digital technology provider, it might sound very unusual, but we have no interest to stay more than needed. And that's why what we say is we want to enable our customers to continue the journey even without us. So, and the enablement has to be done in a way that you use open, and I repeat this, open platforms. Use an open platform that can be learned by the business, that they can retain the knowledge, and that even if we decide to move on, do something else, they still have something of huge value. That's why we use an IoT, a general purpose IoT platform that can be learned. We use a general purpose machine learning platform that can be learned, and we use a general purpose business process management platform. So with those three components, we enable digitization at all 5 levels, and we don't need to be there. So if they choose another vendor, that's equally great. So they can stay with other vendors. We hope to be, of course, to be selected for additional discussions, but the value is there even if we are not there. That's our strategic approach to that. So data resides completely in the control of the client, and the platforms and the ability to work on those platforms resides completely in the control of those clients, of our clients.
Fantastic. Thanks for that, Francis, summary there. Let's just turn our attention briefly, maybe for the last few minutes, to the digital twin. The digital twin, obviously, it gets it's essentially a buzzword again, really, but you know, different people mean different things by it. Maybe we talk a little bit about its impact on product lifecycle management or something like this, in terms of how we can. I mean, we're looking into business processes like we've never done before. So, you know, Martin's example of the stones, you know, it really makes a big difference to how we manage our operations and so on. But then extending that out into other users or let's say partners, workshops, etc. How can this digital twin evolve both on passenger and on freight to enable future applications to be maximized? I think that's a bit of a generic question, but you get my point, I guess. Anyone want to tackle that? What we're doing with digital twins these days, and are we actually using the word?
Can you define what you call digital twin?
Well, I'm talking about a simulation model that's based on the real world asset. Yeah. So, you know, we are obviously trying to understand the asset in terms of its components and the business processes around it and how it's being utilized, and then part of its fleet, in fact, as well. You know, is this something that is it going to be resigned to the history books as a concept, or are we going to exploit this increasingly? You know, how do you see this? Is it something you're working with, David?
Yes, we work on. We don't call it digital twin, but we call it modeling of assets. I mean, and what we are working about is that we gather data and many different type of data, like temperature, position, shocks, everywhere, to first reinforce the confidence of what we detect, because measuring a level when the temperature is high make no sense compared to what the temperature. If you don't know the temperature, the level measurement could be useless. Okay, and especially true for things like time of switching for some parts, mechanical parts, because the oil is not at the same temperature. That's the first thing. The second thing is that what we do believe is that the IoT in train will evolve like this. We first have a set of rich sensors and two rich sensors in the first phase where we gather data and too many data, and then we will equip the rest of the fleet with smaller sensors, because from the first phase we learned that we don't need that parameters, or the one we need just once a day or once a week, whatever. And on the cloud side, people will be able to model the asset on the field just with a few amount of data. And over time, you will reduce the number of IoT in the field, but they will be more intelligent, and they will be just giving you the right data at the right time. Okay, and if with a proper modelization or digital twin in the cloud, you will be able to model what the behavior of your components. Okay, that's the first thing. And for as Mikko said, it's also that you don't need to equip the full fleet. You just need to equip a certain amount of a wagon, so that you have a kind of statistical view of your fleet, which is often enough.
Okay, so we've got time for one more comment on this. Is there anything that anyone would like to add on this topic? Maybe focusing on the product life cycle management part, if that makes sense.
So maybe if I can add just a couple of words to the topic of the digital twin and all this. I think the digital twin is a concept that makes sense if you look at it from the IT perspective, you know, like modeling the assets, as you rightly said. However, I think it has to be extended at the level of the enterprise. So what is the value of modeling, let's say, a specific asset if you don't have the capabilities to predict when this asset needs to go into maintenance? And then once it is in maintenance, do you have the right tools? Do you have the right people? Do you have the right schedules? So you need to look at the complete value chain and then look at this type of predictions along the value chain, so that the predictions that you make in one part of the value chain, let's say at the level of the asset, they become inputs into the next level that you want to do in fleet management, and input into the next level when you do the strategic planning and exercises in this direction. So once this is understood, I think to your point, Daniel, digital twin of the asset, this one is not going to be relevant anymore. It's going to be absorbed into the digital twin, you know, basically into a simulation of what needs to happen from the business perspective, down to the level where, you know, where the business is actually happening, which is where maintenance is happening, when you're selling this asset or renting this asset or leasing this asset. That's the important thing, to increase overall utilization and efficiency out of that.
I think the shock example is a nice example to use for this, because you can have multiple different business outcomes from, if 3G has happened, it's irrelevant, without that context and without that domain knowledge. And I think this is a lovely little example. You can see the heat map. You can investigate it further, and then you get down to the nitty-gritty of what's really happening behind the scenes, and then you can say, okay, we need to train these people, we need to renegotiate our service contract, we need to send inspectors down there, etc., etc. And these are real world outcomes. And it's this iterative thing that once you start, then you start to uncover other things. Guys, it's been a great discussion. We've run out of time, unfortunately. We've reached the end of the session, but I would like to say, first of all, thanks to the organisers again, thanks to Ben and his team. Thanks to AJ, who's behind the scenes, who's working on the technical side to make sure that this all functions and that we don't screw it up by pressing the wrong button, etc. And also, I'd like to say a big thank you to you guys, the speakers, because I think it's been really interesting to get all these different views and perspectives together in one session. So just a quick reminder before we go, 10th of November, taking place in Stockholm, is the challenges, or we'll be attacking the challenges of IoT and big data in particularly Scandinavia. I understand from Mikko's comments that you guys are venturing outside of Finland as well, so I guess you might be going east too. That will be very interesting to discuss these unique challenges. Then obviously we've got the Rise of IoT and Big Data in Rail main event in Cologne next year in May 26th, 27th. So it's a 2-day event. I'll be moderating that event, I hope. And then we can also just mention finally in the user profile on the app, there are some handouts, the relevant documents, the presentations from the speakers. So I'd just like to say, from my side, thanks ever so much, and goodbye, and hopefully we catch up again soon.
Thanks. Goodbye, guys.
Thank you. Goodbye.
Bye.
Thank you very much.
Bye for now.